This revision videocast focuses on Unit 4 energy. It has been divided into 3 sections. The first section is all about the forms of energy and energy transfers. The second section focuses on energy resources and electricity generation, and also the environmental implications of different energy resources. And the final section focuses on heat transfer and thermal expansion. So the learning intentions for the first section are then: by the end of this videocast, you should know the 10 forms of energy, their definitions and examples of where they are found. You should be able to state the principle of conservation of energy and understand its role in all energy transfers. That point is very important. You should know that energy may become dissipated and become less useful, and how it's dissipated. You should be able to describe energy changes in energy transfer devices and identify the most useful type or types of energy produced. You should know the efficiency equation and be able to calculate the efficiency of energy transfer devices. So, having looked at the learning intentions, let's make a start with some definitions. Firstly, what is energy? Energy lets you do things. Another name for energy is work. So when you do work, you use energy. The units of energy are joules. And there are many different types of energy you need to know about. But before we start that, let's think about our units. We said the units of energy are joules. They are often coded in kilojoules. So how many joules are in a kilogram? Well, if we think about some units which are more familiar to us, like grams and kilograms, there are 1,000 grams in a kilogram. Therefore, there are 1,000 joules in a kilojoule. The unit joules is often written as a capital J for short. Now, moving on then to the different forms of energy. Well, what different forms are there you need to know about? There are 10 forms that you need to be able to identify and describe. And the easiest way to learn it is through a mnemonic. And the mnemonic that we use is as follows. Most GCSE kids hate learning energy names. And each of the starting letters then stands for a form of energy. M is magnetic. G is gravitational potential. You can fill in potential there. C is for chemical. S is for sound. E is for electrical. K is for kinetic. H is for heat. L is for light. E, again, is elastic potential. And N, the final one, is nuclear. So most GCSE kids hate learning energy names, and that will help you to identify the 10 forms. Let's begin then by looking at magnetic energy. The energy associated with a magnet is called magnetic energy. And electromagnets convert electrical energy into magnetic energy. Often they use an iron core to increase the strength of the magnetic field. Some devices that use electromagnets are a bell system, or an alarm system, or an alternator within an electric motor or generator. So that's magnetic energy. The next one on our list is gravitational potential. These slides will give you an overview of what each one generally means. An object in a gravitational field has gravitational potential energy. We actually sometimes call it GPE for short, and that is due to its position in that field. If we look at the Earth, the Moon orbits the Earth and it has gravitational potential energy due to the gravitational field of the Earth. So the gravitational field of the Earth keeps the Moon in orbit. So it experiences gravitational potential energy. And then, on a wider scale, the Earth has GPE due to the gravitational field of the Sun, and it orbits the Sun then. Chemical energy. When chemical bonds are broken, they can release energy, and the energy stored in these chemical bonds is referred to as chemical energy. The food that you eat is chemical energy, is fuel for your body, so it provides your body with chemical energy that your body then converts to perhaps kinetic or sound and so on. 3 sources of chemical energy that you need to know about are coal, oil and natural gas. These are our main sources of fuel that we use, and we'll be looking at these in more detail in the second section of the video cast. Sound energy. Difficult concept thinking of sound as energy. Sounds are caused by vibrations, and sound travels in longitudinal waves. Now this is a slight overlap with the sound unit. And sound transmits energy. The louder the sound, the more energy it transmits, and the quieter or softer the sound, the less energy. So louder sounds transmit more energy, which takes them from the source of the sound to your ear. The next one then on our list is electrical energy. This is the energy electrons have as they flow around a circuit. So it's the energy carried by the electrons around the circuit. Electricity is so useful because it's such a convenient way to transfer energy to a desired location or to a desired device. In this circuit, what happens when the switch is closed? Well, when we close this switch, it makes a circuit, and electrons leave the positive of the battery, flow around the circuit, and back into the negative of the battery. As the electrons flow, they carry energy. That energy, when it hits the light bulb, is then converted to light energy. So we have the chemical energy in the battery is converted to electrical energy of the electrons, and that then is converted to light energy and also some heat, because as we'll find, the bulb heats up. Next one on the list then, kinetic energy. Kinetic energy is energy possessed by a mass that is moving. The heavier an object is, or the faster it is moving, the greater its kinetic energy. So the kinetic energy is linked to the mass of the object and also the speed that it is moving. Heat energy. The hotter an object is, the more heat or thermal energy it has. We will be learning more about heat energy in the third section of the video cast, but suffice to say that electrical devices use the fact that as electrons flow along a conductor, friction between the electrons and the conductor's atoms occurs. Whenever you get friction, you get heat. So the movement of electricity generates heat energy. Some devices that are designed to produce heat energy are a kettle, or an oven, or an electric heater, or similarly a toaster or a grill. Any of those applications convert electrical energy to heat energy. Light energy is the next one on our list. Light is a type of transverse wave. We talked about sound being a longitudinal wave,